Today we're diving deep into one of the most thrilling and high-stakes simulations in modern military defense, the engagement between SAM and CRAM systems versus an attacking fighter jet. This video takes us into the heat of a simulated battlefield, showing just how precise, powerful, and complex these modern defense systems have become. As the simulation begins, the radar of the SAM system sweeps across the horizon, scanning for any fast-moving aerial targets. In the distance, a fighter jet pierces through the sky at supersonic speed. It's fast, evasive, and armed, a real challenge for any air defense network. But that's exactly what this simulation is meant to test. How effective is a coordinated surface-to-air missile and counter-rocket, artillery, and mortar system when facing an agile and heavily armed threat from the skies? The jet makes a low pass, breaking the sound barrier, and immediately the SAM system locks on. What's particularly fascinating here is the layered defense approach. The SAM battery doesn't rely on just one missile. Instead, it coordinates a sequence, first tracking, then calculating a firing solution, and finally launching a high-velocity missile at the target. The missile, once launched, cuts through the air with incredible speed, guided by radar and heat-seeking systems. It's not just brute force. It's a dance of precision, physics, and real-time data processing. The fighter jet attempts to evade. You can see it banking hard, deploying flares, and releasing countermeasures in an attempt to confuse the missile's guidance system. And for a moment, it seems like it works. The missile veers slightly off path, but then corrects midair. That correction is due to the missile's advanced onboard AI, which recalculates trajectory using inertial and radar inputs. This isn't just about target locking. It's about adapting in real time. As the SAM engages, we see the CRAM system activate in tandem. For those unfamiliar, the CRAM, or counter-rocket, artillery, and mortar, system is a close-in weapon system designed to detect and destroy incoming threats at close range. It's usually used for short-range threats, but in layered defense, it plays a crucial backup role. If a missile or aircraft breaches the outer perimeter, the CRAM acts like the final shield. Its rapid-firing cannon can unleash hundreds, even thousands, of rounds per minute. And in this simulation, as the jet makes a second pass and gets dangerously close, the CRAM bursts into action. There's something terrifying and awe-inspiring about watching those tracer rounds light up the sky. The rounds aren't random. The system uses radar-controlled targeting to lay down a wall of lead in the projected path of the threat. And it works. As the jet tries to fire missiles at the base, the CRAM detects the launch and responds instantly. A curtain of fire explodes into the air, neutralizing one of the missiles mid-flight. Meanwhile, the SAM system isn't idle. A second surface-to-air missile launches, this time with a different flight pattern. Instead of a head-on approach, it loops around, flanking the jet from behind, an ambush in the sky. The pilot of the fighter is now forced to split attention, trying to evade fire from both sides while maintaining altitude and targeting capability. It's a losing battle, and the simulation shows this clearly. The second missile hits. Not a full impact, but a partial detonation that damages the tail section of the aircraft. Smoke trails behind it as the jet spirals away, trying to regain control. It's not just a kill, it's a disablement. That alone shows how effective modern air defenses can be. Not just destroying, but rendering a threat useless. At this point in the simulation, we're shown detailed overlays of the targeting systems, radar feedback, and thermal imagery. What stands out is the seamless coordination between systems. The SAM's long-range detection and engagement capabilities paired with the CRAM's short-range, high-speed reaction form a comprehensive net of protection. The integration of systems is key here. It's not just one weapon. It's a networked, smart defense grid. The simulation then rewinds and runs a second scenario. This time the jet flies in at a higher altitude with stealth features enabled. This is where the simulation gets even more interesting. The SAM struggles at first to lock on, due to reduced radar signature. But then it adapts by switching to passive infrared tracking, which detects heat differences instead of radar reflections. You can see how much thought and programming went into making the simulation realistic. It's based on actual military doctrine and sensor capability. The missile lock is slower this time, but once it happens, the missile fires with slightly modified parameters, slower acceleration, higher trajectory to conserve energy and allow better terminal homing. The jet deploys flares again, more aggressive this time, and even performs a high-G barrel roll. But ultimately, the missile adapts. It stays on course and detonates near the cockpit. That would be a kill in real combat. What makes this simulation impressive is not just the graphics or effects, it's the realism. From radar acquisition delay to seeker head behavior, from countermeasure evasion to ammunition management, this is a true-to-life military-level representation of how an air defense system would engage an aerial threat. We also get to see the back-end of the CRAM operation, the targeting screen, real-time alerts, and even the ammunition feed mechanism. When the system engages again during a simulated multi-target raid, it fires in short bursts instead of continuous streams, indicating logic-based firing to conserve ammo and prevent barrel overheating. Again, a very realistic touch. As the simulation progresses toward the end, we witness a final coordinated strike, this time 2 jets in tandem. The SAM system prioritizes the higher altitude target while the CRAM tracks the lower one. What's remarkable here is how the AI behind the systems makes these decisions based on risk priority, angle of approach, and velocity. The AI is not just reacting, it's analyzing, choosing, and engaging. Both threats are neutralized within seconds, showcasing that in a real combat zone, even highly maneuverable and stealth-enabled fighter jets can be countered effectively with the right layered defenses. This simulation isn't just for entertainment, it's also educational. It provides insight into the modern battlefield, the rise of AI-powered weapons, and the future of defense technology. It also shows that no single system is perfect. It's the combination of smart sensors, fast processors, adaptable weapons, and trained operators that create an impenetrable shield. As we come to the end of the video, it's clear that modern SAM and CRAM systems represent the cutting edge of battlefield control. Their speed, accuracy, and coordination are what define 21st century warfare. From intercepting hypersonic threats to reacting in milliseconds to surprise attacks, these systems are the silent protectors of strategic assets and urban zones. Whether you're a defense enthusiast, a student of military science, or just someone fascinated by technology, this simulation gives a real appreciation for the complex choreography of modern combat. It's not just about firepower. It's about information, automation, timing, and precision, all coming together in split-second decisions that mean the difference between defense and destruction. This video delivers both cinematic intensity and real-world insight, a rare blend of realism and thrill that keeps you glued to the screen. And as technologies evolve, systems like these will only grow smarter, faster, and more lethal. Thanks for watching, and if this kind of content excites you, there's so much more to come in this world of next-gen warfare.